Snap your fingers right now. Go ahead. Do it. You heard that sound instantly. The snap happened and your ears captured it. Simple, obvious, something we experience thousands of times every day. But here is the thing. That sound did not travel to you by magic. It did not teleport from your fingers to your ears. Something carried it, something invisible, something you cannot see or feel or touch directly. And if that something was not there, you would hear nothing. Absolute silence. Complete and total emptiness of sound. This is not speculation, this is physics, and it raises a question that has puzzled thinkers for centuries. Why does sound need a medium to travel? Why cannot it just move through empty space like light does? The answer reveals something profound about the nature of waves, matter, and reality itself. Let me take you on a journey into the physics of sound. By the end, you will never hear the world the same way again. Start with something familiar. Drop a stone into a pond. You see ripples spreading outward, circular waves moving across the surface of the water. Now ask yourself, what is actually moving? The water itself does not travel outward with the wave. If you placed a cork on the surface, it would bob up and down as the wave passed. It would not drift toward the shore. The cork stays roughly in place while the wave moves through. Think about that for a moment. The wave is not made of water moving sideways. The wave is a pattern of motion passing through the water. Energy transferring from one water molecule to the next. Each molecule nudges its neighbor, which nudges its neighbor, which nudges its neighbor. The pattern travels, the medium stays. This is what a wave truly is. Not a thing moving through space, but a disturbance moving through stuff. Simple enough, right? But this simple idea has profound consequences. If a wave is a disturbance in a medium, then no medium means no wave. You cannot have ripples without water. You cannot have vibrations without something to vibrate. And sound is exactly this kind of wave. When I speak, my vocal cords vibrate. They push against the air molecules near my throat. Those molecules bump into their neighbors. Those neighbors bump into their neighbors. A pressure wave spreads outward in all directions. Eventually, that pressure wave reaches your eardrum. Your eardrum vibrates in response. Your brain interprets those vibrations as my voice. But notice what happened. Every step of that journey required matter, air molecules pushing other air molecules. Without the air, the chain breaks. The wave cannot propagate. The sound cannot travel. This is why space is silent. In the vacuum between stars, there are no molecules to carry sound waves. No air, no gas, nothing to bump into, nothing else. An explosion in space produces no sound. A scream in vacuum goes unheard. Science fiction movies get this wrong constantly. Massive explosions roar through space. Spaceships whoosh past cameras. None of that would happen in reality. Space is silent because sound requires a medium and space has none. Here is the question that should bother you. Why is sound like this? Why does it need stuff to travel through? Light crosses the vacuum of space just fine. It travels 300 million meters per second through absolute nothingness. Light does not need air or water or anything at all. So why is sound different? What makes it dependent on matter when light is not? The answer lies in understanding what sound actually is at the deepest level, not just as a wave, but as a mechanical phenomenon, a transfer of energy through physical contact. And this distinction between mechanical waves and electromagnetic waves reveals something beautiful about how the universe is structured. But to understand that, I need to show you what happens at the atomic level when sound travels. I need to show you the invisible dance of molecules that carries every word you have ever heard. Let me take you inside a sound wave, down to the level of atoms and molecules. This is where the true nature of sound reveals itself. Imagine a room full of air. That air is not a continuous fluid. It is made of individual molecules, nitrogen, oxygen, carbon dioxide, trillions upon trillions of tiny particles bouncing around constantly. At room temperature, these molecules move at roughly 500 meters per second. They crash into each other billions of times per second. Complete chaos at the microscopic level. Now imagine a speaker cone pushing forward. It shoves the air molecules directly in front of it. Those molecules get pushed closer together. A region of high pressure forms. Then the speaker cone pulls back. It creates a gap. The molecules spread apart. A region of low pressure forms. High pressure, low pressure, high pressure, low pressure. This pattern of compression and expansion is what sound actually is, not molecules traveling across the room, but a pattern of crowding and spacing moving through the molecules. Think about a line of people standing close together. The first person pushes the second pushes the third. A wave of pushing travels down the line, but no single person moves very far. Only the disturbance travels. Same pattern, same physics, just with molecules instead of people. Here is the thing that makes this mechanical. Each molecule must physically contact its neighbor to pass the disturbance along. No contact, no transfer. The energy moves through collision, through physical interaction, through matter touching matter. This is fundamentally different from light. Light is an electromagnetic wave. It does not need molecules bumping into each other. It does not need physical contact at all. Light is a self-propagating disturbance in electric and magnetic fields. When a charged particle vibrates, it creates a changing electric field. That changing electric field creates a changing magnetic field. That changing magnetic field creates another changing electric field. The wave regenerates itself as it travels. It needs no medium. It carries its own mechanism of propagation. But sound cannot do this. Sound has no self-propagating mechanism. It relies entirely on the medium to pass the disturbance along. Stop and think about what this means. Light is independent. It carries everything it needs to travel forever through empty space. Sound is dependent. It borrows the medium to exist. Take away the medium and sound simply ceases to be. This distinction seems abstract, but it has real consequences you can observe. Consider this. Sound travels at different speeds in different materials. In air at sea level, sound moves at roughly 340 meters per second. In water, it travels at over 1,500 meters per second. In steel, it moves at more than 5,000 meters per second. Why these differences? Because the speed of sound depends on two properties of the medium: how stiff it is and how dense it is. Stiffer materials transmit disturbances faster. When one molecule gets pushed, it pushes back quickly. The collision happens faster. The wave propagates more rapidly. Denser materials slow things down. More mass means more inertia. The molecules take longer to respond to being pushed. Steel is both stiffer and denser than air, but the stiffness wins. Sound travels faster in steel than in air. Water is denser than air, but also much stiffer when compressed. Again, stiffness wins. Sound travels faster in water. The medium determines everything about how sound behaves: its speed, its absorption, its reflection, everything. Light does not care about mediums in this way. Light travels at 300 million meters per second in vacuum, always, without exception. The medium affects light only by slowing it down slightly, but light does not need the medium to exist. Here is an analogy that might help. Imagine sending a message by dominoes versus sending it by throwing a ball. Dominoes require a chain of physical objects to fall in sequence. Remove any domino and the message stops. That is sound. Throwing a ball requires only the ball itself. It flies through empty space. It needs nothing between thrower and catcher. That is light. Sound is the domino. Light is the ball. Now things get strange, because this mechanical nature of sound creates phenomena you might never have considered. Phenomena that seem almost magical until you understand the physics. Let me show you something remarkable about sound that most people never consider. You can hear around corners. Think about that. Someone speaks in the next room. The sound bends through the doorway and reaches your ears. You cannot see them, but you can hear them. Light does not do this nearly as well. If someone stands around a corner, you cannot see them directly. Light travels in straight lines. Sound curves. Why? This is called diffraction. When a wave encounters an obstacle or opening, it bends around edges. It spreads into regions you might expect to be shadowed. Here is the thing. The amount of bending depends on wavelength. Sound waves have wavelengths measured in centimeters to meters. A typical human voice produces waves roughly 1 meter long. These long waves bend easily around obstacles like doorways and furniture. Light waves have wavelengths measured in nanometers, billionths of a meter. These tiny waves bend so slightly around everyday objects that we perceive light as traveling in straight lines. Same physics, different scales, different behaviors. This is why sound fills rooms so effectively. It bounces off walls. It bends around obstacles. It reflects and diffracts until it reaches every corner. But the mechanical nature of sound creates something even more interesting. Something called interference. When two sound waves meet, they combine. If their high-pressure regions align, they reinforce each other. The sound gets louder. If a high-pressure region meets a low-pressure region, they cancel out. The sound gets quieter or disappears entirely. This is how noise-canceling headphones work. They detect incoming sound waves. They produce identical waves but inverted. High pressure matches low pressure. Low pressure matches high pressure. The waves cancel. Silence. Think about that for a moment. Sound can be destroyed by more sound. You can add noise to noise and get silence. This seems almost paradoxical until you understand that waves are patterns, not substances. You cannot cancel matter with more matter, but you can cancel patterns with opposite patterns. Now let me show you something that connects sound to the deepest structures of matter. Everything vibrates. This is not poetry, this is physics. Every atom in the universe vibrates. Every molecule oscillates. Every solid object has natural frequencies at which it prefers to vibrate. Strike a tuning fork. It vibrates at a specific frequency. 440 cycles per second for standard A. The tines flex back and forth, compressing and expanding the air around them. A pure tone emerges. But here is the beautiful part. The tuning fork vibrates at that particular frequency because of its physical structure, its length, its thickness, its material. Change any of these and the frequency changes. Every object has resonant frequencies, natural modes of vibration. Push an object at its resonant frequency, and the vibrations build up. This is resonance. You have experienced resonance countless times. A wine glass shattering when a singer hits the right note. A bridge swaying when soldiers march in step. A child pumping their legs at just the right rhythm on a swing. Same pattern, same physics. Energy building up when the driving frequency matches the natural frequency. This phenomenon connects sound to music, to architecture, to engineering, to the quantum behavior of atoms themselves. In atoms, electrons occupy specific energy levels. They can only exist in certain states. When they jump between states, they emit or absorb electromagnetic radiation at specific frequencies. These quantum jumps are like atomic tuning forks. Each element has its own set of frequencies, its own spectral fingerprint. Sound does not work at these quantum scales. The wavelengths are too long, the energy's too low. But the mathematics of waves and resonance apply everywhere. Standing waves on a guitar string, electron orbitals in atoms, acoustic modes in concert halls. The equations share the same structure. This is what physics reveals again and again. Different phenomena at different scales. Same underlying mathematics. Same patterns echoing throughout nature. Now I want to show you the ultimate limit of sound, the boundary beyond which mechanical waves cannot exist, the silence at the edge of matter itself. Let me take you to the edge of where sound can exist. I told you that sound requires a medium, molecules bumping molecules, collisions transferring energy. But what happens when the medium itself breaks down? Consider this. Heat a gas and its molecules move faster. They spread apart. The gas becomes less dense. Sound still travels, but differently. Keep heating. The molecules move faster still. Eventually, the gas becomes so hot that atoms themselves break apart. Electrons separate from nuclei. This is plasma, the fourth state of matter. Sound can still travel through plasma. Barely. The physics becomes complicated, but mechanical waves persist. Now go the other direction. Cool a gas down. Molecules slow down. They move closer together. Eventually the gas becomes liquid, then solid. Sound travels through all of these. In fact, sound travels faster in solids than in gases. The molecules are closer, the material is stiffer, collisions happen more quickly, but keep cooling, approach absolute zero, something strange happens. At temperatures near absolute zero, quantum effects dominate. In certain materials, vibrations become quantized. They can only exist in discrete packets called phonons. Think about that for a moment. Just as light comes in packets called photons, sound comes in packets called phonons. At the quantum level, sound is granular, discontinuous, made of individual units of vibrational energy. This is not just theoretical. Physicists study phonons to understand heat conduction, superconductivity, quantum computing. The quantum nature of sound has practical consequences. Here's the thing that amazes me. Sound seems so classical, so everyday. You hear sounds constantly. Nothing seems quantum about a voice or a musical note. But at the deepest level, sound is quantum mechanical. Every vibration you have ever heard was carried by countless phonons, packets of mechanical energy bouncing through matter. The classical world we experience emerges from quantum foundations we cannot directly perceive. Now let me connect this to the largest scales. Sound waves exist in stars. In the sun, acoustic waves bounce around the interior. They cause the surface to oscillate. By studying these oscillations, scientists probe the sun's internal structure. This is helioseismology, using sound to see inside stars. Sound waves exist in the early universe. Before atoms formed, the cosmos was a hot plasma. Sound waves traveled through this plasma, regions of compression and expansion. When the universe cooled enough for atoms to form, those sound waves froze in place. They became patterns of density. Those patterns became the seeds of galaxies. Stop and think about what this means. The large-scale structure of the universe, the distribution of galaxies across billions of light years, all of it traces back to sound waves in the infant cosmos. Sound shaped the universe, not metaphorically, physically, mechanically. Waves of compression and expansion in the primordial plasma determined where matter would cluster, where galaxies would form, where stars would ignite, where planets would coalesce, where you would eventually exist. The same physics that lets you hear music governed the formation of cosmic structure. Same pattern, same mathematics, different scales. Here is what I find most profound. Sound is temporary. It requires a medium to exist. Take away the medium and sound vanishes. It leaves no permanent trace in empty space. Yet sound is also eternal. The patterns it created in the early universe persist today. The echoes of cosmic sound waves are written in the arrangement of galaxies. You are a consequence of ancient sound. Vibrations from the beginning of time shape the matter that became you. When you snap your fingers, you create a small echo of that primordial process. Compression waves spreading through a medium, energy transferring through collision, patterns propagating through matter. The same physics that structured the cosmos structures your voice. So why does sound need something to travel through? Because sound is not a thing. Sound is a relationship, a pattern of interaction between particles, a conversation between molecules. Without the medium, there is nothing to vibrate, nothing to compress, nothing to expand. Without matter, sound cannot exist. But wherever matter exists, sound is possible. From the quantum vibrations of atoms to the acoustic oscillations of stars, from the words you speak to the echoes of the Big Bang, sound is matter talking to itself, and you are listening.